Welcome to the RAOB program's Advanced Merge module. This powerful utility can merge thousands of soundings from two different time series files into hydrostatically balanced composite soundings that are appended into a single time series CSV file. It can compress 2 weeks of manual work into a single 2-minute process. The Advanced Merge module is contained within its own executable file, the raobmerge.exe file, which can be directly called from your screen's desktop icon or from a batch file. The merge utility can also be called from the RAOB program's menu system. For example, just go to the menu bar's merge option, and there you see two different merge options. First is to create a single merge sounding. This allows creation of only one merge sounding at a time. It requires use of the standard merge module and has its own video. The second option, create a time series file containing many merge soundings, opens up the Advanced Merge utility. Here we have the entire RAOB Merge utility control panel. All merge options can be seen at a glance. The only options not visible are the special data processing options, which can be seen by using this Data Options button. Upon clicking on it, we see the familiar RAOB program configuration panels, and specifically the Data Processing Options tab. When processing any of these data types, it is very important that the applicable options are properly set. We'll first look at the Input File section. Here you identify the source data paths for the temperature data and for the wind data. Both source files can be in the same path, but you must then specify different search patterns in these fields. You should also test these paths by clicking on the Test Path buttons. Note that RAOB will merge any sounding data for which RAOB has decoders for. This is only true, however, for text and ASCII formatted data, not binary data. As with all RAOB data processing, you must have access to the necessary data decoders. It is also important to note that from the temperature data files, RAOB will merge available vapor density and liquid water elements. Station elevation and station coordinates will be taken from these files first, and if missing, will be taken from the wind data files. When RAOB processes the wind data, wind direction and speed and vertical wind components, if available, will also be merged. And a final note about input data is this Extra Data Reminder button, which says that if either the temperature or wind data contain extra data as provided by RAOB's CSV data format, that extra data will also be merged. This can be any user-defined data with up to 2 data types. Next, you must also specify the output data paths. The individually merged soundings will be placed in the path identified here. After all the individual files are combined into a single time series file, it is placed in this multi-sounding path field. All files are saved using RAOB's CSV data format, which can then be used by RAOB to produce soundings and time section diagrams. There are also options to purge pre-existing files for storage management purposes. You can control how old these files are before purging, where use of the 0 value forces a purge prior to each merge, and the 99 value never purges any data. You can even FTP the merged single and combined files if needed. Just check the appropriate box and set the FTP logon information with these respective buttons. You also define the file names of the merged sounding files. The single sounding file names can be any acceptable file name text of your choosing, but they must also contain time tokens, because RAOB uses these time tokens for time interpolations during the merge process. The multi-sounding file name, on the other hand, does not require time tokens because it is a standalone file. The file name can be any acceptable file name text. And as mentioned before, all output sounding files are saved in RAOB's CSV data format. Now we'll look at the settings that control the merge process. First is the time interval option. This interval setting determines how many merge soundings will be created. The smaller the time interval, the greater the number of merge soundings. Each sounding will be sequentially created according to this time interval and given a file name using the format specified for the single sounding path. For this example, we'll create merge soundings at 15-minute intervals. Even though the temperature file contains data at 40-second intervals and the wind file contains data at 15-second intervals, the individually merged soundings will be created at 15-minute intervals, using the date and time notation specified by these time tokens. Next, you can choose whether merged soundings will only be created if they contain both temperature and wind data. If left unchecked, all available data will be processed. This can result in output soundings containing only temperature or wind data. For this example, we'll leave this option on to ensure all soundings contain temperature and wind data. For this demonstration, the temperature file contains data over a 24-hour period, while the wind file only has data for the last 12 hours. Therefore, the merged output will only cover a 12-hour period. Next, you can choose whether to interpolate temperature and wind with respect to time. Otherwise, temperature and wind values will be directly taken from the nearest sounding without temporal interpolation. It's okay to leave this off if your data has high temporal frequency, such as the source data used in this example. But if you want to use the last option, then this interpolation option must be checked. And now for the last option. When checked, RAOB will interpolate winds in the vertical, so that wind data will only be saved at the same height intervals as the temperature data. In other words, for every temperature data value, there will be associated wind data. And now we'll discuss three options which help control how the merge process starts and ends. You can use the timer feature to automate periodic merging of your data. If this option is not used, then you must manually start the merge process with the Merge button just below. These two options help define what happens after the merge process ends. The first one, create a time section diagram after merge completion, automatically activates the RAOB program and uses the merged time series sounding file found in the multi-sounding path to automatically create and display a time height diagram. Or you can always just click this diagram button anytime after the merge process is complete. The second option, exit RAOB merge after completing a batch DOS command, is self-explanatory. The structure of the merge batch command can be found from the help file, or by hovering the mouse over this option to view the tooltip information like so. Okay, we're all set to start the merge, so we'll click the Start button. The bottom row of command buttons are now replaced by progress bars, where each phase of the merge process can be monitored. During the temperature and wind initialization phases, the number of soundings being processed are displayed below. These initialization soundings are being created in a temporary file folder, which is automatically erased upon the merge completion. Remember that the individually merged soundings will be created in this folder, and the multi-sounding file will be created in this folder. We'll now fast forward this initialization phase to save video time. When the merge is complete, RAOB posts a message indicating the number of merge soundings created. If using radiometer data or other special profilers that provide optional data capture modes, they will also be displayed here. Remember that these data modes can be pre-configured with the Data Options button. And so we can now close this merge panel and open the main RAOB program and use the cross-section display to create a time height diagram with our newly created multi-sounding file. Or we can do it the easy way and just click the diagram button and have the time section created automatically. But before we do that, remember the file name structure of this multi-sounding file that we defined here, because we'll soon see that again. Okay, let's hit the diagram button. The RAOB program opens with the cross-section view, and in just a few seconds our time series file of 48 soundings is transformed into a time section diagram, where each sounding is plotted at 15-minute intervals. And since the winds only existed for the last 12 hours of the day, only those hours were included in the merge process. First, note the title. It contains the original file structure as defined on the RAOB merge panel, but two things have changed. First, the phrase RAOB time section has been added to the file name. And second, the CSV extension has been changed to TXT, because it's no longer a CSV file, it's now a dataset file in a text format. These changes are necessary to differentiate it from the source file, because this title name was used to save this dataset to the same path as the source sounding file. Okay, we can see that the winds were transferred during the merge. But how about the temperatures? This can be verified in several ways, but we'll just demonstrate two. First, we'll click on any sounding line, and we can see an overlay of a mini sounding with temperature and wind data. Second, we can perform a temperature analysis of the entire diagram by selecting the Analyze menu and then the temperature option. And we'll add one more item where we'll use the Meteogram option to plot the mixing height line. Notice how warmer temperatures and southerly wind flow correlate to mixing height. Before I forget, the fact that there is a no wind region in the upper middle section of the diagram is not an error. It just reflects the available wind information from the source data. Now, let's again look at the Merge Module Options panel. And assume we again perform the merge, but with the Interpolations option turned off. This turns off temporal and vertical wind interpolations. To see this, we'll minimize the merge panel, load the same merge diagram, but from another file for demonstration purposes. Then select the Compare menu and place our original diagram in the top panel. Now, let's again select the Compare menu and load the same merge data, but as processed with the interpolation options turned off. Here we can see hardly any difference in the horizontal because both datasets had high frequency sampling. But there is a difference in the vertical. You can see more wind data in the non-interpolated diagram because it retains the vertical wind distributions of the source data, while the top diagram interpolated the winds to coincide with the temperature data levels. In other words, where you see a wind plot, there is a coexisting temperature value. And now we'll make one last comparison, but first recalling the Merge Module panel. This time we'll turn off the option to simulate merging, regardless of whether both data sources have temperature and wind data. So we'll again minimize the merge panel and select the Compare menu. And this time load the top panel with a diagram which was created without the option which ensured temperature and wind data. And as expected, the first 12 hours only have temperature data, while the last 12 hours have both temperature and wind data. We can see the temperature data by analyzing for the temperature on both diagrams. That completes the advanced merge module video. Thank you for watching.